All right. So as we established here in our, for the video purposes, we can have an HTML page such as test1.html. That is a valid HTML document. We can have our style tags, but now we can also have a script tag. We can also do, if we wanted to, inline script. So then we have our JavaScript within our script tag. The browser will compile that up and say, and understand what that means and execute it right away. Otherwise, we can create a test.js file and move all of this code in there. But if you notice, there is no script tag around it. Much like the CSS file, there is no styling, excuse me, styling tags around it. So then with that being said, we can just kind of link to it using the source tag in that way. So moving on to types and variables. I'll put it on full screen. All right, so we're gonna kind of look into some more syntax of JavaScript. We kind of just look at console logging and working with the browser itself. But we're gonna start to look at some more syntax a little bit closely. So we're gonna do a little intro to data types, what they are. In JavaScript, there's all these concepts of types, numbers, strings, comments, concatenation, and variables. It's good to know for any programming language what these data types are before you start learning the language itself. So data types. So you can almost think of these like pieces of Lego. These data types, data and data types, data and data types. So you have data, obviously, and you have a type of that data. Are the building blocks to any programming language. You need to know what this data, what the context of the data is. So you need to, it helps us organize our information and determine how our programs are going to run. It's important to be aware of these types of data and when to use them. And we're going to learn how to define and manipulate the primitive types of data. So primitive types of JavaScript are as follows. They're numbers, booleans, strings, undefined, and null types. Now, I can just tell you numbers, booleans, strings, those, those are pretty straightforward, to be honest. There is a very big distinction from JavaScript and other programming languages. JavaScript can be very tricky to master, and it comes around the trivial types, these undefined and null types. I got to tell you, the null type is the source of many defects and many times spent when a value you expect to be something and it's not. And in JavaScript, there's this concept of undefined, and undefined is very, it's a very tricky thing also to test for, to write some kind of protection against something when it may be undefined, and there may be reasons why. And when you really understand sometimes why something's undefined, it can be related to the browser itself and how the life cycle of the browser works. Sometimes things at a certain point in time are not defined yet, just because the browser has not finished rendering or finished loading, and there's different stages of a life cycle that happens. And sometimes you need to put checks in place that you cannot, you cannot say render or populate some kind of drop-down container without list items because you don't have them yet. And anyhow, you can get many errors in your console, and your whole application can throw big errors because of these types. So it's a little different, very different here. Yes, go ahead, somebody.
Hey Mike, suppose if there is like a form which has a first name, a middle name, as well as a last name, and suppose we have a person who doesn't have a middle name, In that case, will the middle name be stored as a string or a null or an undefined?
You're saying if it's not provided in the form? If it's not provided in the form, it can be even an empty string. When it posts backs, it can still be a string. It'll be just empty. It all depends on how the form is posting back, and
Okay.
and there's various ways to handle these types of situations too.
So it could be an empty string if there is no explicit type conversion done before the postback. But is there any specific best method, or what is like the the best way in which developers actually code a situation like this in order to
Well, we
save
can get,
space?
yeah, well, I mean, ideally, to be honest, when you get right down to where you persist the data before it even enters the database, it has some checks or defaults on it, so that if in, I mean, there's a big pipeline that goes, right? And there can be errors at any time, but when you hit the database itself, if you're expecting middle name to be a string, at least an empty string and not a null, you would either just not update that record, or you would default it in some way that you would want. But I mean, many ways, even I mean, there in, okay, when we talk about ES6 and those kind of things, there's ways to default parameters so that if it's undefined, it defaults to a default of your choice. So as we start getting into more JavaScript, there's a lot more handlers to handle this type of situation, right? Some I'll tell you right straight, some dirty ways of doing it is just checking with an if statement, and if it's some value, then you default it in kind of a manual way. But there's many there's many ways. That's a tough question to answer, to be honest, because there's many ways to do it, right, on different layers. Now I'm complicating things because I'm thinking of the whole pipeline, but at the very least, if you have a form and there's a null value coming in, you can check if it's there or not, and there's ways of doing that with truthy and falsy. And if it doesn't happen to be there, you can default it yourself. So,
Thank you.
yeah. All right. Thank you for the question too. It gives context to this undefined and null type, and giving you a reason to understand that they are very tricky to deal with. But once familiar with these data types, we can store them in the variables. So we need to store these values in the variables. And that in itself is interesting matter for JavaScript. Data types allow us to reuse and manipulate data throughout our code. Yes. Point. If you have if you have something at a top level, and when I say top level, I mean I'm referencing something called scope. But say you have defined a variable somewhere called a, and you say that, and we say that a is true. We can use that value later on at some point, or maybe it could be first name of the form submission. Is the first name is Mike. Somewhere in our code, we can always reference the first name that was submitted. We can look up, and if it was maybe a better context is its current country. So the current country or language is English in Canada. Then throughout our code, we can reference that the fact that the current setting for the language is English, and that is a way of reusing this data, setting it one time and using it throughout. However, we can also always overwrite that, and that can be a problem as well in big code bases. Numbers are what they sound like. Defining a number in JavaScript is actually pretty simple. The number data type includes a positive or negative integer as well as decimals. Entering a number in the console will return it right back to you. And you can also do that arithmetic calculation is pretty easy. Basically, type out an expression that you want to, and it'll come back to you like a calculator. So if we use our dev tools, and we try to do this here. So if we have so we said, what was it? 5 comes back as 5. we did 5 plus 5, comes back as 10. 200 times 5 plus minus whatever plus, well, it's like a calculator, right? But you will get into very interesting issues here when we can talk about types. Like we could say, is 4 equal to true? It's going to say there's some problem with that, right? You're trying to assign, it's trying to do some type of assignment there. Because it looks at the equal sign and says that is not, that 4 is already a primitive number, and you can't assign a primitive number to a Boolean number or even a string. So we need a storage mechanism for it, and there is no storage here. You're basically trying to assign 4 to hello, and the engine or the compiler is saying that's not possible. You cannot do that, and that's right, because we have no container for either of these at the moment. But a number is a number. Good to know. We can also use these mathematical comparisons, which is great. Less than, greater than, equals to, and not equal to. So now you need to pay attention here, because this is where things get a little complicated also, is in JavaScript especially. You have these that we all know, greater than, less than, equal to, fine, that's great. But if you notice, JavaScript has a concept of equals, double equals, and there's pound equals not equal to. So these two syntaxes here are used quite a bit. In fact, there's another confusing thing about this sign. You may often see 3 of them together, and then as well there may be an extra one here, and that has a different context. But for us, equal to is double equals, which is a bit strange, right? It's handled in a different way. So if we go back and look at that example now, if we said 4 double equals hello, now it's not going to throw an exception, because it knows, the browser knows it's not going to assign it, it's trying to compare. So it's a little bit better now. It says, okay, 4 is not equal to hello. So the number 4 is not equal to the string hello. But in other languages, we should not even be able to get to this point. We should not really be able to even compare these kind of these primitive types, because we would have defined them in a different way. That something called strongly typed languages would not, would prevent this kind of thing. But JavaScript is kind of wide open. I need to stress that. Anyhow, just some of the mathematical operators. Obviously, we have 4, 5 is less than 10, 5, right? So on and so forth. So we can actually use some of those operators. And then there is also some, in the case of 4 is equal to hello, will give us false. We can use that other method to say 4 is not equal to hello, which is the exclamation mark, or they call it the bang, and the equal sign, and that will give us true. All right. So a little confusingness around JavaScript and this kind of syntax there, but it's kind of a behavior in itself. Comments are, again, we talked about in HTML, we can use comments to explain our code. The comments in JavaScript are different, though. In the browser, we'll look at it in a different way. We will not have that closing greater than sign with the dashes of HTML. I'll show it in a second. We need to do it with the /. Anything written after the / will not be executed. You can also have multiple lines, a multitask, if you use the / and star, and then close it off. So yeah, that's a lot to know, right? I mean, typically you'll see this kind of this is what I see the most, is this kind of style. I'll show you in a second. This one is not so readable in a way, but you can do it if you want to comment out lines of code. So if you had Visual Studio Code, not to be confused with Visual Studio, which is a .NET compiler, but if I had this right here, and I wanted to write some comments, you know, this is what it would look like. The HTML version was like this, HTML comment, and you can see right away my Visual Studio Code editor is complaining right away, barking at me that it does not like this. It doesn't expect this to be in a JavaScript file. Therefore, this will fail and probably my code will break. If I go to refresh my page, I'm sure when I go to look at that file there, it'll probably break if it does, if I do look at that one. 1 second here. If I go to lab 6, I go to the examples. Here it is. So if I go to test, and I'm going to make sure I don't select the JavaScript file, I select the HTML file. I select that and I take a look at it, and it should throw some kind of console log error. So it did not. So really what this is then, okay, so what this is saying, so if you ever see this, this is something called linting. So the editor will actually not like the syntax. So in fact, this will not throw an error, but it will actually give you some information that it doesn't like what's going on. Maybe it'll actually try to help me fix it. No, so really it's telling me there's something wrong with the syntax for best practices of JavaScript. And that's called linting, which is a good thing. So you got to remember, if you see these squiggly lines in here, it doesn't necessarily mean the browser's going to have a problem with it. It's that Visual Studio Code is trying to give you some hints on what's going on. So it's best like this. A double quote is a double forward slash is a JavaScript comment. And I usually see this kind of thing going on where I see multiple lines of comments that explain a story. You know, this will console log, right? Nothing to see here at all, right? So that basically will, you know, you can see many lines of this kind of coding. And they're trying to say that if you, instead of writing out this format, you can do star /*, and you can kind of close this off. So anything now, if you notice, all my code now is blanked out, which may be the quick way that you want. You want to kind of exclude that code that doesn't work in that way. But you got to remember, if you don't close it out, now your code doesn't work anymore. So you have to quickly put the star and the slash, and then you kind of escape all of that out and basically ignore it. And then here is your JavaScript code that is still relevant underneath the commenting out. All right, sorry, I had a question there. Is JavaScript a primarily event-driven programming language? Is it event-driven? No. So by itself, it's not event-driven, but the browser is, the engine is, the whole mechanism of the web API in the browser is event-driven. So JavaScript is like a syntax language, but it borrows from the engine that is built within the browser, and event-driven means all the events that you may have, the clicks, the selects, every time you tap something in the box. Now that is JavaScript, but underlying that uses an API that's built into the browser, like a web API, and those events are driven through that. So you will have many event-driven pages, but the syntax of JavaScript, you know, does not trigger all of that. It's triggered through the API. When we get into it, and the web does it so well. The web is incredible at being event-driven with JavaScript syntax at the heart of it. And in fact, when we get into Node.js, the creator of Node.js thought, wouldn't it be great to kind of replicate that event-driven design on the web to a server? And they get some type of, and they try to replicate that in Node.js, which is why it's so very popular. All right, so I'm still sharing, and that's kind of talking about what is to come, but the syntax itself. And right, so we have comments here, which is good to call out because there's different ways to do comments. Strings, so strings, pretty straightforward. I mean, we are going over these primitive types, but there's a big catch. There will be a catch eventually that we'll have to talk about. It's not as straightforward as just of these items being in their own primitive types. A string can be, or a text string is a series of characters like John Doe. You may have already used strings when you did the console.log message. So it's correct to use either. So this is another thing. So you can use double quotes or you can use single quotes as long as you're consistent. And the compiler will kind of understand that you're trying to get at being a string. So it kind of figures out for you that double quotes is a string, which is really nice of it. It's very flexible. If you tried to do this in C#, which is a strongly typed language, the compiler will not build. It'll give you errors. It'll give you it'll give you a build error, not just a console error. It'll actually tell you cannot use single quotes if you're trying to define a string. That's a character. So it can kind of go back and forth. And yes, that's kind of what we're getting at here. So string can be anything there in the quote. So they're saying that hello is fine. Also single quotes is fine. Hello, single quotes is also fine. So if I did the single quotes, it translated it to double quote. Great. But what it's saying is if I type hello, the double quote and end it with a single one, now it says it's unexpected token because it's expecting, much like HTML tags with an opening and close tag, it's expecting that if you open it with a double quote, you should expect to close it with a double quote. And that's what the expectation is. So even in a sense, if you add hello with a single quote and then you closed it off, it would be perfectly fine, right? So in the case of if you had some Irish names, right, Jimmy O with a quote, O'Reilly or something like that, you know, that will not throw an error. You don't have to escape it in any way. It'll treat it. It'll basically kind of escape that single quote. So strings, but if you kind of look at how kind of a preface a little bit to what an array might look like, and it's basically saying that strings hold, these characters hold space and memory, and they each have some type of, we're going to talk about arrays, and arrays are storage mechanisms, but they each have an index. So if you look at this in behind the scenes, you could actually, you know, you could actually go to the E at index number 1 and you know, splice it out, substring it. So you can substring things based on their indexes, and you can easily convert them back. And if you were to look even deeper, you would see that this H actually holds a storage, you know, like a reference point to it. This looks like an array, a data storage thing. And we're going to talk about arrays and how we would traverse these different indexes and how you can do different things with them and loop over them and all that stuff, fun stuff. But strings can easily be traversed and concatenated and those types of things. So strings are collections of characters enclosed in single or double quotes. You can use a string to represent data like sentences, names, addresses. Concatenating them is pretty simple too. So that's another thing. If you notice here, we can easily concatenate strings. It's hello string plus world equals hello world. And this is where JavaScript gets a little weird. You can actually take a string and you can add it to a number. How in the world does that work? So what JavaScript will do, it will basically, through ranking or whatever system, it'll take this first value on the left and say, okay, now I'm expecting a string. It'll go through and evaluate the expression, which would be 5 times 10, 50, and then it'll concatenate hello with the 50 value, because it assumes now that I'm starting off with a string. You want me to concatenate something. Even though it's an integer, I'm going to transform it into a string. If you think that's weird, like I said, JavaScript is very quirky. It's not strongly typed, and sometimes, a lot of times, it doesn't make sense. And because it is so flexible, is, to be honest, why it is so popular and why it's exploded, because it has allowed many authors to go off and make their own their own frameworks out of the fact that it's so loosely coupled and dynamic. Java is not this way. Java is a strongly typed language, and you could not get away with anything like this. Your compiler will bark at you furiously if you try to do something like that. I'll stop that as question here. Is Java private? Okay. What does dynamic mean? Okay, so strongly typed dynamic means that we can change on the fly. Is that concept of it's kind of the one we were going to talk about, is that dynamically typed means that if you have a variable a, let's look at it. Why not? I'll demonstrate it while we're talking here. Let me get out of full screen here. And we will go to the console window because this one needs to talk, to be honest. If this console window is getting a little annoying to you, and maybe I will put it on the left panel so we can see it up here, a little higher up. If you're working a lot in here, there's a little button here called Clear Console, Control L, and we'll start fresh. Dynamic means, in a sense, and we're jumping ahead of ourselves, but we could say, if we define a variable using var, and we say a equals to 5. Okay, that's a is 5. Okay, that's great. What if we said a equals to true? Now a is true. Okay, a equals to string, hello. Now a is hello. But wasn't a equals 5? Yes, it was. Now I can turn it back to 5. The fact that I can dynamically change the type of this is why it's a dynamically typed language. You cannot ever do something like this in Java itself, because Java doesn't really want things changing in this way. It doesn't want things to jump around. Now there are ways in ES6, when I talk about the newer versions of JavaScript, to lock this down and prevent this from happening. But just know that vanilla JavaScript, kind of like the JavaScript that's been around for a while, this was a common thread that can quite happen. You may have the carpet pulled out from under your feet when you have something like tax rate. Tax rate is equal to something really crucial, right? 0.5. Wow, that's a lot of percent, right? 0.5 tax rate, and then somewhere down the line somebody says, well, the tax rate now is going to be, I don't know, it's some other developer in your code says, well, it's Canadian or it's USD, because they didn't understand the fact that you had set the rate. So now somewhere you may have some logic that depended on that, and now it's going to give you some weird number. Maybe you have currency times the tax rate. Now let's see if it'll actually do this, times tax rate. Well, now I have something called NAN, which is not a number, because now it's all messed up, because now we're mixing and matching, right? And this is what dynamic is. This is a problem. This can be a problem, or it can be a very powerful thing. But later versions and more modern versions of ES6, we lock this down so that this cannot happen, that you cannot keep changing a. If it's defined once, it's only defined once, and unless you want it to change in different scopes. But in Java or C#, this would never happen at all. And that's one of the quirkiness of JavaScript. And I'll keep mentioning JavaScript is quirky, and oftentimes can be a little confusing. All right, continuing on. So that's right. So strings can be strings. String can also be concatenated with numbers. Up is down and down is up sometimes. And it's not, and it's, I didn't write it. Just remember, this is how the browser interprets it. So if it's a little confusing, this is why we have ECMA, to kind of give us better versions of ECMA script to solve some of these things. But at the heart of it, it is a dynamic language, right? We're following some basic definitions of a programming language context of variables. Variables provide us with a name storage. So when we say A, we know that A is a reference to a storage place in memory called A. I'm sure it's not called A in memory. It's probably called X5001 or something with a pointer. But when we're programming, when we define A, the compiler will know what we're talking about and make a place in memory for it, and then store the value in there at some point. And the variables are basic units of storage of a program. So a place to keep our stuff. So variables are used to store information to be referenced and manipulated in the computer program. In programming, a variable is a value that can be changed depending on the condition or information being passed to the program. So it can change, obviously, unless with more modern versions of JavaScript, we can mark it as read-only. So naming conventions. So the recommended JavaScript styling guide for variable naming is the concept of camel casing. So like a camel is the first word is lowercase, all followed by words that are uppercase. Hold on, a question here. Oh Lord, why can't I see all of this? Type conversions are done automatically, right? Type conversions are done by the compiler. Is there any functions of JavaScript to validate the type of variable? Well, by nature, no. But we have we have other ways of checking. There's some kind of mechanism of type of, but it's a lot of checks, right? You often see some check type of this variable is a number, or type of, because the types switch so fast. You know, there is, I'm trying to think of other ES6 versions coming out where they have different types of type checking. I'm thinking more of when you get into the frameworks. When you get into frameworks like Angular and React, they build libraries, or they include libraries to prevent all of this. But we're talking about vanilla JavaScript. That is not a framework. And this is the base. And the base is really, there's not much ways to enforce this kind of things, right? All right. So am I sharing? Yes, I'm sharing. Camel case. So try use a variable name that accurate. Okay, when you are trying to create variable names, that you need, it's very good practice in programming to describe what exactly the data is about. If you have a credit card number, you might as well call it credit card number. Don't call it XYZ data or whatnot, right? You don't want to get into that situation where somebody cannot read your code. You don't ever want to have a situation where, you know, I have something that is a credit card number. So if I have a var and I'm just going to call it, how about I just call it some number? How about I even call it number 2 equals to, you know, a credit card number? Well, how in the world would anybody know what that is later on? And I'm putting it as a string. Because it's so close to number, I would have no context later on what that means. So, you know, and you're best to name something like that, you know, in camel case, credit card number. If you notice, the first word is lowercase, and then the other words have an uppercase on them. So to me now, when somebody is asking for the credit card information, you would know that, okay, well, there's a variable called credit card. It must have some reference back to credit card, is what they're trying to say, is what they're trying to get at. And same when eventually you build your own functions and methods, you need to clearly define what they are. If you have something called delete database or drop database table, you know, you're not going to want to call that, you know, page reload, or something very nondescript, like you know, you could call it whatever you could call it, 5000x. I mean, that doesn't make any reference. That will just confuse everybody. and make for very bad practice, and probably a lot of churn in terms of budget and time trying to figure out that code base. So we want to make sure that we are naming our variables in a very descriptive way. We want our programs to tell a story, and to the reader it is kind of clear about what things are doing. Even if they really don't understand all the syntax, they can kind of make it out that, hey, I'm looking at some code that deals with bank transferring or something like that. It's very important. So not using camel case, right? It's not going to break it. It's recommended by the style guides for clean code, and it's easy to read. So in this case, you have a final subtotal and you have a text. You're using camel case here for multiple words, but if there's only one word, you might as well just keep it all lowercase in one word. So yeah, it's very nice for readability. Much better than if you were to go back to your lines of code and have a bunch of variables that are really loud, like credit card number, right? Even when you kind of look at that already, you can kind of tell like it's kind of very loud, right? And you're doing everything in caps, expiry date, right? I mean, after a while, it's not very. It just seems like everybody's yelling, to be honest. Go ahead. Yes, questions. Couple questions.
How about those variables, values of which do not change? For example, pi. So do we declare them with a capital naming convention, or?
Yeah, those are perfectly. So if there's a constant that never changes, you'll often see that people will take a little bit of a different approach. For sure, they may put credit card number in uppercase just to signal to everybody that this is in fact is a number that doesn't change, that is used everywhere. So that's fine. But those are usually at the top of your code, and they're always in the same spot, way at the top, and that's perfectly fine for these important things like codes or things like that, like maybe a province or state may have USD that doesn't change very often. That's perfectly fine to do something like that. All right, doesn't lead to more bugs. Doesn't this lead to more bugs in code? Uppercase? No, it doesn't. It doesn't lead to more bugs. It's a best practice not to do it, but when somebody sees something in uppercase, oh, being dynamic, of course, yeah, it leads to a lot of bugs. Oh man, does it lead to bugs? So many bugs. The nature of JavaScript, it leads to bugs. Now, that's why there's these things called frameworks that people start to gravitate towards to kind of prevent this. Like Angular mimics. Angular is a framework, a JavaScript framework, but they try to mimic that strongly typed system to prevent the rug from being pulled under you when you're coding. How do you define global variables? Well, we'll get into that. Usually they're at the top, and they have a global scope. But we're jumping a bit ahead there. So yeah.
Mike, is it common practice to concatenate a credit card number? So I don't have the whole number together. I have it in 4 or 5 different files that I put together.
No, not really. You would normally, if you're concatenating credit card numbers, it's probably an issue with your database developer, because they should probably be encrypting that information, and then when you get it back, it's decrypted.
Okay.
Yeah. Yes. Although, to your point, I've seen many databases that have clear text. Your credit card may be in some old database in clear text, by the way. So hopefully you change it. But yes, I've seen it. But that's a security breach, and hopefully PayPal doesn't store it in that way. So string indexes. So we kind of got to that. We're kind of dancing around the fact that there is something kind of like in the Marvel universe of a big bad. There is not that array is a big bad, but there are things out in the universe that are out there that we're not talking about, such as global scope. Oh, global scope could be the big bad. It could be, it's definitely big and it's global, but things like arrays. You'll hear about arrays, and we kind of talked. We gave a little bit of a glimpse of it, but strings can't have an index. So an individual character you can use to find that location of the string is called its index. So you can actually put the index of the character inside the square bracket, and you can actually pull it out, which is pretty neat. So if we were to, do that example there, something, or even number 2. So if we have credit card number still defined here, credit card number, and I wanted to pull out the second digit there, it's 3. If I wanted to access the end of it, it's 5. However, if I wanted to go greater than the index of it, because I don't know exactly, can I give it a length? So if there is an option of having a length, I can check what's the length of that string. Now these are built-in kind of utilities. Okay, it's 10. So I know my credit card number is 10 in length. If I try to grab the index that is, say, 20, which is greater than the index, I'm going to have an undefined, because now I'm going way outside of the string and it doesn't know where to find it. But each one of these have a place in memory that I can pull from, which is very useful. Otherwise, I would have to traverse through every single one to find the position I'm looking for. So that's called the string index. All right, so we define that. We might run into these issues. Oh yes, I want to also show this quickly when we're dealing with strings. We already talked about that already, but if I had credit card here, and we know credit card is a string, to your point, if we did have a credit card number, which is a string, we could actually kind of, if we wanted to, we could do that. We could also, append another number to it, like an expiry date or something, or we could, 0215. It's not going to stop us. It's not going to make any sense, but we could do that. If we had a fragment, we could put it all together, and it's going to allow us to do that. That probably would not process, but yes, go ahead. Some people have their hands up. Yes.
So, Mike, I mean, this credit card number, this is actually written as a string, but is it possible to convert it into a number for processing? I mean, we do have like explicit type conversions in other languages. Is there any such feature available here?
I forget the exact syntax. I think it's, I'm trying to think now if it's to int or as number. I think there's a way to convert it to int. No, that's C. That's C++. As integer, something like that. So there are ways to typecast them back to int array number. There are ways of doing that. No, that's not it. When we get into this kind of type conversion, it gets really, to be honest, I need to look it up, because when I'm writing this thing, this is how far it is. There's so many times when these values change on you, and you need to check the type of it to convert it back. Now, when you're dealing with the front end, usually you have a mechanism to pass it back to the back end, and the back end usually has type conversion. The type conversion will basically say, okay, well, if it's an API or some web call, chances are the whole thing's going to be a string. And what I mean is, if you look at the networking tab of any kind of application, you'll see a bunch of calls in there where you'll have an API endpoint in the networking tab, and you'll see it's all a string. It's all a string. And let's see if Netflix has any of these in here. All right, so even if you look at this request here, it's called a request, and you can tell here that they have some parameters in there, a source, a fetch, and there may be some numbers in there, but to the server, this is all a string. The server itself then will do all of the type conversions, and then that will go through a layer that'll go to the database, and then the database will actually have the correct value itself. So there's a lot when we talk about type conversion. I could tell you so many stories about issues around that and defects that keep me awake at night. So it's a big topic. We will be talking about this for many weeks to come. All right, we may need to use quotes within a string to prevent syntax errors, to denote the beginning and end of the string. Hold on for that in 1 second. So we sometimes we need to use these backslashes, double quotes, single quotes, new line, and tab. So yes, some of these older versions we sometimes need to, basically, kind of exclude them or prevent syntax errors here by escaping them. If you want to do embedded now this is vanilla JavaScript. So there's a concept of vanilla JavaScript, and when we learn the newer features of ES6, there's ways to solve all of this stuff. But we're learning vanilla JavaScript without the new features. Once we get to the new features, we will appreciate them so much more, because we're going to know some of these issues. There's a way of writing the syntax below that we don't necessarily need to do this, but we would be using more advanced features to that. Someone had a question. Go ahead. No? Okay, I thought somebody had a hand up, but if they didn't, I'll go to the next slide. All right, so let's suspend reality still in the fact that that we don't know any of these other utilities and features, but comparing strings. So another way to work with strings is to compare them. If you've ever seen these operators, the double equals and the not equals, which is the pound and the equal sign. So when you compare numbers for equality, you can use these, but you can also use them with strings. So for example, let's compare the string hello to hello. This will return false. So this is looking at, hold on for a second, try to get to the console window without this Zoom taking over. All right, so let's clear my workspace here. So it's saying that if I have a string which is called hello is equal to lowercase hello, true. All right, but is now this equal to uppercase? It is not, it's false. Is it equal to capital hello? It's not. So it's a way of comparing the string itself, much like the way we compare 5 equals to 10 or 4, right? It's false, whereas 5 equals 5 is true. So it gives a little indication that we can actually compare these strings in that way. Comparing strings. So that'll return false. Case sensitivity, you can compare the string where case matters. While both use the same letters, they can appear in the same order. However, one may be capital and the second string has a lowercase h. So therefore, really, uppercase h is not equal to lowercase, right? And that is true, because it probably has a different code for this this uppercase character. So internal workings, in JavaScript, strings are compared character by character in alphabetical order. Each character has a specific numerical value coming from the ASCII value of printable characters. So for example, A has a value of 65 and lowercase a has a value of 97. So that's how it can determine the difference between the strings. Booleans. Now this is true or false. So a variable can take two values, true or false. A Boolean variable is mainly essential in evaluating the outcomes of conditionals. So we will get into conditionals. Those are building blocks of programming in general, not just JavaScript. When we talk about conditionals, we're talking a lot about, if statements, and or those kind of if-else logic, in a way. So the result of the comparison is always a Boolean value. So in this comparison here, we have a variable a that is 10, and we have a variable b that is 20. We want to make a comparison against it, so that we're going to say if a is greater than b, and the outcome of that should be true, then logically we are going to go to this block, which says a console log variable a is a higher value if a is greater than b. Now, if that expression is false, that expression will then fall to the else case and skip this entirely, that whole block, and then it'll print out variable b has a higher value. Now, that's probably one of the best reasons that you would use a true false for some kind of logical comparison. But you may not use it right away in your JavaScript code. You may have some kind of toggle or something where, is this feature on, or include hours in the calculation. You might have a value that you pass back to the server for processing. Sometimes we call it a flag, right? It's the flag on or off. It's commonly referred to as like a feature flag or something like that. Right, and you could also, we're jumping ahead here a little bit, but you could also put you could also probably put an if statement inside of your console log. You could say if 5 equals to 5, then I want to console log true. Let's see that. True. However, if I want that to fail completely, say this is equal to nothing, it should say nothing. So this will be false, therefore it will not execute that. If we had something like this, let's see if we can fit it all in one line. Console log false. So it doesn't like that because they don't have it. It doesn't like how we're doing this inside of the console log. I'm sure we could wrap it in a better way so it would understand what we're doing. But in this console log, it doesn't like this kind of thing. So we could wrap it in a mechanism such as a function, but we're not there yet. But just know the fact that we could evaluate something in the console log in this manner. Called conditionals. All right, so then we get into the weirder stuff. So null, so we have different types here. We have null. Null refers to a value of nothing. We have undefined, refers to the absence of a value. And we have NaN, which is not a number. So sometimes a null value, at least the null value, you can sometimes pass it around like it's null. But when you get undefined, it's the absence of the value, and those ones are tricky because they can happen when, like I said, when the browser reloads or something like that. Not a number, so not a number. We came across it already. We tried to multiply 5,000 against I think a string, and it just came back NaN. So that was kind of an error that happened. So it's returned when an error happens within a number operation. For instance, you wrote some code that performed a mathematical calculation and it failed to produce a valid number. So NaN might be returned. So if we wanted to calculate the root of a negative square number, it will return NaN. Trying to divide hello by 5 will also return that. So let's take a look at that. Hello divided by 50 will give us an NaN number right there. So it's a mathematical calculation. It's not allowing us to do that. However, if you use the plus sign, it may, again, it does that conversion because concatenation is also plus, but also an expression is also plus, can also use a plus. So that can be a little confusing exception there for strings and concatenation. So that's another quirkiness that may happen. And don't worry, we're going to get into some quirkiness, so it's coming. Is there any function in JS to validate if there isn't a variable is null? So, there's not really, hold on, let me get into this. Sometimes, most often, you're going to see many checks that look like this, and they're going to be checks that are, is, some variable. So we have var a equals to 5, but you may have checks that are like if a is equal to null, right? It's not always the best kind of way to do it, to be honest, because because sometimes we may have to check we may need to check not only for null, but we may need to check for undefined. And there's there is better ways to do that. And we'll get to those in a second. So, right. So sometimes we want to capture null and undefined in the same breath. And there's other ways of doing that. So equality. So we're kind of talking about equality. So we can use double equals, and we can use the exclamation mark equals with number equality. We can also test for equal values when comparing different data types. It can lead to very interesting results in type conversion. So we have that concept, type conversion. So in the case of regular comparisons, the operands on the either side of the double operator are first converted to numbers before comparisons. So what that means is when we have this situation here, string number 1 is equal to 1, and it'll say true because in behind the scenes, there's a conversion going on. At the same time, if you do 0 equals to false, it'll also be true because internally, and again, quirkiness, false can be 0 or 1, right? It's like it can be like a electrical circuit, right? Or binary number, 1 and 0 is kind of on or off. True false is a way of saying on or off. So it can convert it down. And it can say also that empty string is equal to false as well. So equality is a very strange subject in JavaScript, and it's best to really kind of highlight that now and learn it. In the case of, so therefore, an empty string, a false, and 0 are all considered equal. Similarly, a 1 and a string 1 and 1 are also considered equal. If we don't want to convert the operands, we use a strict comparison. So what that means is, this can be weird, obviously, right? So they're saying that, okay, they're saying, not they're saying, I'm saying, that if we have this kind of thing going on, that's going to be true, but that's very confusing to me. So what they're saying is that you can use a strict comparison, which is triple equals. So triple equals is basically telling the compiler, check the type, be very strict about it. You know, this makes sense to me. A string 0 is not equal to a Boolean value. So this is a very strict way of comparing. So I would say in your code, use the triple equals where possible, so you don't have this type conversion happening or this equality thing happening. You can basically say that, empty, 1 is at the same time not equal to true, right? So again, we're adding an extra equal to it. So this is something called strict comparison. We're being extremely strict, and we're telling the compiler, don't do that. Don't pull out the rug out from under me. Equality is a strange thing. So anyhow, that's the takeaway to that. So JavaScript is known as a loosely typed language. I'm trying to finish up quickly. As a loosely typed language, as we notice, it is changing quite a bit. When you're writing JavaScript code, you do not need to specify data types. Instead, when your code is interpreted by the JavaScript engine, it'll automatically convert to the appropriate type. This is called implicit type coercion. You've seen many examples when you tried to concatenate strings. So internally, it's having this strange behavior. And it makes JavaScript very unique and can lead to quirky behaviors, very, very quirky behaviors when doing operations in comparison, because you're mixing the data types. And it's extremely frustrating sometimes when you have something like that. So you can see hello plus 10 plus false. All different types, they all combine down to a string. What is going on here? But that can happen. So these topics are getting very high level, and I think there's 2 more, so we might as well just kind of go through those two slides, and then that's a lot. It's a lot. We'll stop there. Right, so that can happen for sure. So strongly typed versus loosely typed. So this is what I was referencing. Strongly typed language is a programming language that's more likely to generate errors if the data doesn't closely match. For instance, C#, Java, even Angular, they're very strongly typed. The compiler will fail if you try to do any of this type of thing. But because JavaScript is loosely typed, you don't need to specify it. It can lead to errors that are very hard to diagnose, but your browser code may still load up and you may not know that these things are changing on you. And that can lead to many, many problems. So, right. I'll just finish this slide for 1 sec. I'll take that question. So if strongly types, this is like C#. Int is an int. I'm saying that count is an integer. It will always be an integer. It'll never change on me. I have faith that the compiler will tell me if it fails, if it changes. Same with string name, Julia. Name will always be a string. Number will always be a number. Float will be a price. Price will be a float, and these will not change. If it does, I will know right away. I will know right away when I build my code. However, in JavaScript, we're scripting, and all of these numbers can change on us because they have the equivalent of this var keyword here. Yes, it's a strange world we live in. But right, strict equality. So like we said, we can use this double equals will give true, but we want to be stricter. We will use 3 equals, and that will give us the expected result. Same with this 0 equals false is false because 0 is a number. I don't want it to do a type conversion. False is a Boolean. This makes sense to me. All is well in the world here. Whereas with this does not make sense to me if I don't know why it's happening. So where possible, use strict equality. So when you use double equals or 1 equal, the not equal operator, Java first converts it, does the conversion. If they're not already the same type, it does a type coercion. This is the behavior you do not want. It's considered bad practice to use it. That's why sometimes when I look at this, I'm like, what do we mean? Because I never use it. I always triple equals because it avoids so many errors. So I eliminate this whole block of code that we just talked about with conversion because I don't want to deal with that. I always use strict comparison. So in JavaScript, it's better to use strict equalities to see if numbers, strings, and booleans are identical to their type and value without doing that conversion first. To perform the strict comparison, we use the additional equal signs on these. And then all makes sense in the world, in a sense, for a little while. All right, I had a question here. So yeah, I think we answered that. What's the difference between 1 not equal and 1? Yeah, right, we answered that, sorry. That's the strict conversion. All right, so 9:15, like we said. So I would say continue on. I'm gonna stop recording.